Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 4D. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 26, Pune, India. The 10th edition of this conference is being held in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th till the 21st of January 26. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for a presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I'd like to introduce you all to our session chair. We have with us Dr. Paras Kothari, who is a professor and head at Getanjali Institute of Technical Studies, Udaipur, India. He is experienced head of training with a proven record in professional training and coaching industry. His technical expertise includes PHP, databases, mobile application development, Windows Communication Foundation WCF, and Android development, contributing effectively to the academic leadership and skill-oriented training. We welcome you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Now I'd like to start with the paper presentations. We have with us, firstly, paper presenter Shalaka with the paper titled A Comparative Study of Text Representations and Classification Models for Cognitive Distortion Detection. Ma'am, if you're ready, then you may start with the presentation.
So, good morning to one and all. My name is Shalaka Shirsagar. So, I will be presenting my paper. My paper ID is 599, and my topic for the paper is a comparative study of text representation and classification models for cognitive distortion detection. So, my outline of the presentation will be I will be starting from the motivation of why I chose this particular study, then literature survey, what is my problem statement, then what I found, that gaps and findings, then proposed framework of my topic, results, comparative analysis, limitations, then conclusion and future work. So first of all, I would like to explain why I chose this particular topic. Currently, I have chose this particular topic of mental health disorders because we are facing that there are many mental health disorders. Like we can roughly say 1/4 of the population is currently suffering from some or the other mental health disorders, but those are not discussed particularly, and due to the stigma, and also there is a lack of. There is a lack of mental health practitioners also. So if I think that if we provide some kind of a tool, or at least enhance the way they will detect these kind of disorders, will help the society in a great way. So that's why I chose this particular topic, that to have some kind of a technological advancement in the field of mental health disorders. So in the past decade, I would like to explain that machine learning and NLP has become very famous for detecting the mental health text in a normal text. And usually, this kind of text came from a social media, that people post a lot on the social media. And if we try to analyze the text, that text contains some clues that we can actually analyze the clues, and understand if they are having some kind of a mental health disorder. So there are tools, those were developed with the help of machine learning and NLP, but those were mostly depending on finding out whether a person is having the anxiety or a depression or ADHD or PTSD. So in a larger context, they were trying these tools or utilizing this machine learning NLP tools to find out them. But what we need to understand is this particular text also contains the some very important details. For example, cognitive distortions. So there are almost 10, 11 cognitive distortions. Those are found by the Beck and Burt. And these cognitive distortions are very much important for finding out whether a particular person is inclining towards some kind of a disorder, mental health disorder. So if we try to find out those particular distortions in the normal text, it will be a huge help to find out a disorder. So my work is my work is for analyzing those particular distortions in the normal text and then classifying them into different classes. So each and every class has a different type of cognitive behavioral therapy, that is CBT, that can be applied to a particular person. So classification is very much important in the context of finding out this distortion. So this is my motivation, I explained. So for this study, I had done some literature survey. So these are the papers that I have been studying, that revolutionizing mental health sentiment analysis with the help of BERT Fuse, a hybrid deep learning model. So my study basically revolves around evolution of machine learning, deep learning, and transformer based models to classify the cognitive distortions in the text. So I have been studying these particular models, though those were used for classifying the text into whether it is a person is into depression or whether a person is into ADHD. But very few I found the study which were focusing on finding out and classifying these cognitive distortions. Cognitive distortion, I would like to say, these are having the names like all or nothing feeling, mental filter, magnification, then overgeneralization, labeling, mind reading. So these are the classes that I would like to study. I studied those classes, and with the help of machine learning and deep learning and transformer based models, I classified them. Then again, with the help of the literature survey, I came to conclusion that I need to focus on finding out the evolutionary details of how the model evolved for finding out these distortions, or are there any papers currently working on finding out the cognitive distortions. So this also motivated to study in this matter. So I found the problem statement, like despite the success of sentiment analysis in modeling the emotional polarity, current NLP system falls short in finding or capturing the structural semantic characteristics for these cognitive thinking patterns. So like I said, these are the distortions like catastrophizing, mind reading, overgeneralization are psychologically in theory, but in practice, in the computational framework, there are very limited researches. So that was my particular problem statement. Then I worked on these particular gaps for finding out the classification of mental health issue in the natural text. Then there is also an opportunity to integrate this particular study in the clinical usability. Currently, I will be working in my PhD for that. For this study will be helpful to me, that if I integrate the actual clinical usability of my model or developed model, I will be having some validations that whatever my model is finding out or classification of distortions are valid or not. So that will be my future study. And right now, my proposed work is developing a model for classification of cognitive distortions, and where I have been analyzing three modeling paradigms, like classical machine learning, deep learning, and transformer based learning. So in classical machine learning, I have used TF-IDF with support vector machine and with linear regression models. In deep learning, I have used BiLSTM with word-to-vec embeddings and GLOVE embeddings. Then in transformer-based learning, I have utilized the bidirectional encoder for text representation, that is BERT. So this was my typical framework that I have been working on, that I have collected. I have received a data set from one of the literature review. I found a good data set, so I used that data set, I pre-processed it. Then I for feature extraction task, I have used this TF-IDF, which is a method from the machine learning. Then word to vec, which is the method from the deep learning, and glove, also it is the method from the deep learning. So with the help of these feature extractions, I have used this classifiers. For machine learning classifiers, I have used SVM, linear regression, and glove. And for deep learning classifiers, I have used BiLSTM. And lastly, I have used BERT. So my major motivation was to see how these models are evolving, and what advantages we might get by utilizing the advanced models for this text classification. So with the help of the experimental experiments, I have got this result that TF-IDF and SVM gave this accuracy, and I have got the highest accuracy with the help of the BERT model, which got the 0.56, and it's 56% of the predictions were correctly observed here. So I would like to explain what the TF-IDF actually does. So TF-IDF is nothing but term frequency inverse document frequency. So in this particularly, if I have a text, the frequency of a particular word in the text will be counted, and by using the support vector machine model and linear regression model, I am able to classify them into different classes that I have earlierly mentioned. Now, with the help of that, I got this macro F1 0.31 and weighted F1 0.48. So, macro F1 is a very much important metric for measuring the performance, because accuracy alone cannot get the results when we are talking about the classification, or we are having different classes. So then the word to vec and glove are the text representation or feature representation, where we are going where the words or sentence will be converted into deep semantic dense metrics. So with the help of that, the limitation of the TF-IDF was it was not having any particular it was not following any particular word order, and word to vec and glove follows a word order, so we get the semantic relationship between the words in the sentence. So that was the advantage. So I got that from utilizing these two models. Then I use the BERT model, which is already trained, or it is, we can call it as a pre-trained data model. So with the help of Wikipedia and these sort of documents, it has already been trained on. So with the help of BERT, initially I got a very low accuracy, because it was not fine tuned. Then I fine tuned that particular BERT model on the basis of my data, that is the mental health data. So with the help of that, I received the highest accuracy than the previous two models. So that was a huge difference. So I got to know that by using the advanced transformer based model, my aim to classify the cognitive distortion is succeeding. I also got a very good macro F1 and weighted F1 in case of BERT. That means class-wise analysis was also improved with the help of BERT model. So this is the result. Then this was the comparative analysis. So I compared the class-wise F1 comparison. As I earlierly said, that F1 score is important for class-wise comparison or analysis. So I
Excuse me,
analyzed
ma'am.
for all the classes. Like
I'm
no
really
dis-
sorry to disturb you, but I'd like to remind
Yes,
you of the time limit.
yes, ma'am.
Sorry.
Ma'am, can you repeat?
Uh,
Hello?
I think Shalaka, you come to the conclusion, result conclusion, and future.
Conclusion. Yes, yes, sure. Yes, sure. So conclusion here is that I compared all the machine learning, deep learning, and transformer based approaches for this cognitive distortion detection, and where I came to know that the BERT achieved the best overall performance due to bidirectional context, and the TF and IDF was a very good at accuracy than the deep learning model, but it is also good for the better interpretation result. That means we can create an interpretable model with TF IDF, but it will be working on a very smaller data set. But if we are considering a huge data which is actually required for such kind of mental health related researches, so BERT has achieved, or transformer based can achieve a relatable performance as compared to the other models. So this was my conclusion from my study, and these are the future work that I'll be doing on this study also. Thank you.
Okay, Shalaka, any question from the session? Any
Yes.
other participant? Okay, Shalaka, I want to know that which data set were used for the comparison, data set or data sets, whatever. Means what was the
So
source of data set?
I have used this data set from, I have mentioned in the references also that I downloaded a particular paper. It was published in 2021. So I got the link from that paper and I downloaded the data set from Kaggle only.
And the size of the data set was?
It was having 4,000 samples.
4,000 samples
It was
from
actually
a single geographical area or from?
It was no, it was a diverse data. This geographical data was not clearly mentioned here. That was also my concern,
Okay.
that we have to consider the geographical area while considering the data. It was
Because
a
cognitive
slightly,
distortion sometimes affected by the culture and so many other factors also,
yes,
right? So
yes, correct.
one thing which is good, not good in our Indian culture, may be good in the
Yeah.
American culture. So we
Correct.
cannot not find of that. Okay.
Yes, yes, sir.
And like there is one overgeneralization. Overgeneralization is a very common phenomenon, right? So how would you measure this and compare with others?
Overgeneralizations. You are specifically asking for overgeneralization.
Because that is very common phenomenon. That is very common factor, which is you can say in Indian mentality, it is almost every third person is occupied with this.
Yes, sir. So that's why the conceptual overlap is there in these classes. So it can overgeneralization. We can say that we are overgeneralizing certain thing, that I am a failure, for example. That is overgeneralizing. We can say that is the overgeneralizing. But whenever we are
Yes.
considering in the context of machine learning, NLP, so the more we train data, it will give you accurate results. So it will be depending on the number of samples we provide to the model. So only it will learn, because we are able to learn, we understand the context, but machine will only understand the context if we provide more and more samples to it.
I think we should give some demographic factors also while we are generalizing with this, right? Okay, nice work. Very good. All the best for your further research. Thank you.
Thank you so much, sir.
Yes, over to you,
Thank you, sir. Thank you, ma'am.
Sheetal.
We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Manali S. Chugale with the paper titled Active Noise Cancellation System Using Edge Device. Ma'am, if you're ready, then you may start with your presentation. Ma'am Manali.
Yes, ma'am. Yes, ma'am. Hello, everyone. Good morning. Am I audible to you?
Yes, ma'am, you're audible.
Okay. So our topic name is Active Noise Cancellation System using Edge Device. My paper ID is 483. So I'm from SIT College of Engineering, Hetrao, Ichalkaranji. So contents of my topic are introduction, literature review, problem statement, then proposed system design, specification of components used, testing of active noise cancellation system, simulation waveforms, then conclusion and references. So let's start with the introduction part. We know that nowadays acoustic noise is increasing due to transformers, compressors, and engines. So also conventional passive noise control techniques are unable to avoid this noise. So we are using right now passive noise control techniques like barriers, enclosures, silencers, and earplugs. But but these are but these techniques can't characteristics like frequency, phase, amplitude, and velocity changes. But ANC system must be flexible and adaptive to control this effectively. So I have referred several papers, so I have taken the key references from that. So many authors worked on this. 1 second. Many authors worked on this, but still literature gaps are there. But they cannot. But I got to know that they can. The ANC systems cannot handle the time varying noise. Also, the complexity still remains there. Also, high computational is one of the burden. Limited due to limited research solutions, they are unable to cancel out the time varying noise. Actually, the problem statement is traditional passive noise control methods are not effective to cancel out low frequency and time varying noise produced by industrial machines. So, existing ANC systems are now struggling with non stationary noise and often require complex and high cost processing hardware. Used in our experiment ADC analog and digital converter microphone with operational amplifier. We have used Raspberry Pi 4 and digital to analog amplifier and then speakers. So this is a proposed system design. So we have taken Raspberry Pi 4 here, microphone sensor, then anti-noise generating speaker, low pass filter speaker and LCD display. So these are the specification of components we have used. So we have conducted a test of active noise cancellation system in our enclosed physics lab. As shown in figure, the unwanted noise is produced by mobile phone and it is recorded through microphone, which detects this noise and it will convert it into the electrical signal. Then after processing, the signal is amplified using operational amplifier. Then analog signal from microphone is then converted into digital data using ADC, means analog to digital converter. Then Raspberry Pi 4 processes the noise in real time. So we have used here Python codes. So through that Python code will generate the anti-noise signal. So we have implemented here FFT, fast Fourier transform. So these are our simulation waveforms. So figure 4 shows 3 layers. Figure A shows original sound plus noise. Figure B shows anti-noise signal. So which is exactly opposite to the original sound plus noise, means it is inversion. It is inverted 180 degree. So figure C shows result after cancellation. This figure shows the simulation waveforms displayed on digital oscilloscope. So we have successfully cancelled the noise. So let's come to the conclusion. So Raspberry Pi use best ANC system successfully cancel out the real-time noise signals. So it is a low cost and it is feasible in changing noise environments. Testing showed that effectiveness of reduction of low frequency continuous noise. So we have successfully implemented hardware and digital processing system to achieve this. So in future we can integrate AI ML and also we can implement this whole system in textile industries. So we are also going to file a patent for this. So these are the references we have used in our whole. So I have taken this key references only. Thank you.
Okay, Manali.
Yes, sir.
Is this any question from the session? Okay. So, Manali, is this your project?
Yes, sir. I am a guide of students, sir.
Oh,
This is
great.
actually students' project, sir.
It is students' project, and you are working as a faculty.
Yes, sir.
Okay. So, Manali, can you give me why you selected the edge device Raspberry Pi, while the Jetson Nano kind of good are there for ANC?
Yes, sir. Good question, sir.
Thank you.
But sir, this is my also first project, sir. So
So,
I
is
am
this
a guide of
availability?
students. Yes.
What I want to know is this the availability of Raspberry Pi on the scale? or you
Yes, sir.
want to find the basic, it is the availability of Raspberry Pi because it is easily available, right?
Yes, sir. Yes, yes. It
System.
is easily available.
So is this the availability only, or you want to select some basic set? You want to set some of the basics based on the Raspberry Pi, and then you further want to research on other edge technologies.
Sir, it is easily available, so we have choose this topic, and also we will extend this with AIML. We want to integrate this project with AIML with further students with further different groups.
Okay. Because there is a lot of work is going on in these days, especially on
Yes,
this
sir.
noise
Yes.
distortion method.
Yes.
So
Yes.
that's why it is my suggestion also that you go with another also and compare the results, and you will definitely will find some better options there. Yeah.
Yes, sir.
Thank you, Manali. All the best.
Thank you so much, sir, for your suggestion. Thank you so much.
Yeah. Over to you, Ishita.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to invite paper presenter T. Nikita with the paper titled AI-Driven Renewable Aware Load Balancing in Hybrid Edge Cloud Environment. Ma'am, if you're ready, then you may start with the presentation.
Yes, I'm sharing my screen.
Sure, ma'am.
Mm, is it visible?
Yes, ma'am, it is visible.
Okay. So, good morning, everyone. I'm Nikita. I'm here to present my paper, AI-driven renewable aware load balancing in hybrid edge cloud environment. This is cloud computing project. So, I'm here to present with my teammate Samir and Dr. Beena. We are delighted to present our research paper, which is titled AI-driven renewable aware load balancing in hybrid edge cloud environments. So we know that in recent years we have witnessed an exponential growth in cloud computing, edge computing, and Internet of Things systems. These technologies power applications such as smart healthcare, intelligent transportation, real-time surveillance, financial platforms, and smart cities. So, we all know that hybrid edge cloud environments face dynamic overloads, making critical for performance and low latencies. Existing load balance strategies overlook renewable energy availability, leading to high carbon footprints. So, our project aims to develop an AI-driven and renewable aware load balancing framework that dynamically adapts to workload and energy variations. However, this rapid digital expansion comes at a cost, massive energy consumption. Data centers today consume energy equivalent to small cities, contributing significantly to carbon emissions and environmental degradation. So, this brings us an important challenge. How can we design computing systems that are not only fast and scalable, but also sustainable and environmentally responsible? So this our work attempts to answer this question by combining artificial intelligence, machine learning algorithms, Kubernetes, renewable energy awareness, and also hybrid edge cloud computing. We all know that these are latency sensitive and compute intensive applications. Edge nodes process data closer to users, that is routers, while cloud servers handle large scale computation. In such environments, workloads are highly dynamical, geographically distributed, sensitive to delay and energy constraints. Traditional load balancing algorithms focus such as CPU utilization, network latency, throughput. Unfortunately, they do not consider the availability of renewable energy sources. As a result, our systems rely heavily on non-renewable power, which also may make operational cost increase. Then this is the data set we have taken. This data set is taken from Kaggle, which is also called time series 30 minutes data sets. This is called time series 30 because for every 30 minutes in hybrid edge cloud environment, renewable resources are regenerated. The purpose of this is to analyze workloads, energy consumption, and renewable availability to develop predictive models and intelligent load balancing strategies. So here in this data set, it approximately contains 12,000 time series records collected at 30 minutes for over a 1 year across multiple edge and cloud nodes with 10 to 12 system and renewable features. So in this data set, we have CPU, memory, latency power, resource usage, and also we are calculating renewable energy resources like solar power, wind power. And also we have environmental factors like weather and external influence, like it can be heat, cold or humidity, evaporation, etc. So this is the sample of our data set. As I told, we have 12,000 records. In this, we have this is the sample. Then this paper we have taken as a base paper for explaining our project, as it aligns similar to our project. The title of my base paper is Renewable Aware Geographical Load Balancing of Web Applications for Sustainable Data Centers. So here in this paper, the problem statement explains as data centers have high energy costs and carbon footprint. Renewable energy is intermittent and hard to analyze. So so in this paper they have proposed a solution which is a green load balancing algorithm which routes web traffic to data centers with the most available solar and wind power. So as a key feature, it's a reactive method that requires no prediction of future energy, making it proactive and efficient. As a result, they have obtained using ML models. We have got minus 17% as brown energy use, and also costs have reduced to minus 22% compared to standard methods. So we have taken papers, some of the papers which are aligned with our project. So I would like to say that this first paper is about hybrid big data optimization, which is essential in green computing. This even though this paper has used AI algorithms like RMSSD and AHE algorithm, it has some research gaps like latency issues, resource constraints, insufficient integration of ML, which in ours we have integrated. We have solved this issue of ML algorithms. Then overall, I can say like these are the papers which we have taken. Then when it comes to methodology, our proposed systems follow a structured multi-stage methodology. Stage 1, data collection. We continuously collect system level metrics from both edge and cloud nodes. These include CPU and memory utilization, queue length, network delay, task execution time. In parallel, we also collect renewable energy metrics such as solar energy generation, wind power availability, environmental influencing factors. This dual data collection ensures that both performance and sustainability metrics are considered. Then, if you come to stage 2, we have named the stage 2 as predictive modeling using machine learning. To enable intelligent decision making, we apply supervised machine learning models such as random forest, support vector machine, and XGBoost. These are the 3 ML models we have used for our project. These models are used to predict short-term workload demand, renewable energy availability. Accurate prediction allows system to anticipate future conditions, improving scheduling efficiency and energy utilization. Then comes stage 3, in which we have used AI-based load balancing algorithms, which are also called as optimization algorithms. Once these predictions are available, we use bio-inspired optimization algorithms. So there are 2 important algorithms in our project. One is ACO, which is also called as anti-ant colony optimization, and also PSO, particle swarm optimization. So ant colony optimization is effective in dynamic and distributed environments, which often mimics the collective intelligence of ants. That is why it's called as ant colony optimization. And when you come to particle swarm optimization, PSO, this model swarm behavior enabling fast convergence towards optimal solutions. Both algorithms evaluate latency, resource utilization, renewable energy availability, and carbon footprint. This results in an adaptive scheduling mechanism that balances performance and sustainability. Then comes stage 4, where we have evaluated the performance and also we have displayed the visualization. System performance is evaluated using end-to-end latency, throughput, energy efficiency, and carbon emission reduction. We also visualize system behavior using Prometheus and Grafana dashboards. These both are used for visualization and monitoring the real-time dashboards, and also for real-time analysis. Then this is my flow chart where I have explained until now. First, we have collected data from the data set, then pre-processed, then we have used scheduling algorithms like ACO and PSO, and then we have used ML algorithms to predict the model. Then we have also deployed best model to evaluate carbon footprint. Then some of the tools used in our project are Docker, Kubernetes, and Helm, Prometheus, Grafana. So Docker is used to containerize ML models, which we have used in our project. And Kubernetes and Helm is used to orchestrate Prometheus and Grafana. Prometheus is used to collect metrics and monitor the dashboards. And Grafana is used for visualizing the metrics in dashboards. Then if you look at difference between ACO and PSO, from my analysis, ACO adapts better to rapidly changing workloads. PSO converges faster under stable conditions. This comparison demonstrates that hybrid optimization strategies may be more effective in real-world deployment. If you see this search strategy, ACO uses probabilistic strategy and PSO uses social influence and deterministic strategy. Some of the applications for
Excuse me, ma'am.
ACO will be.
I'm
Yeah.
really sorry to interrupt you, but I'd like to remind you of the time limit.
Oh, yes, I'm coming to results. Next is the results. Yeah. So, so this is the difference between ACO and PSO. So these are our results. For ACO, we have evaluated total execution time and average CPU power usage and also average memory usage. And also for PSO, we have evaluated the same metrics. Then these are the Prometheus and Grafana dashboards. Like these are the dashboards in which you can see how much energy is consumed for every 30 minutes. Then, these are the Grafana dashboards where you can see the scrape duration, memory usage, and also how many samples are approached. So, these are the ML models metrics. We have seen that XGBoost has performed very well, and then random forest, and then comes SVM. Then we have used this data set time series predictions for comparing the all the models. We have training time comparison. Then these are the graphs for renewable resources. Then these are the plots for all the algorithms like ACO, PSO. These are the evaluation metrics. So overall gaps and challenges would be like we still haven't had standardized evaluation, like we are and then we have to differentiate between reactive and proactive scheduling, and also the main thing is limited scope of workloads. So, I would like to conclude that this project will bridge the gap between AI-based workload optimization and renewable aware computing in hybrid edge cloud setups, ensuring sustainability while maintaining performance. Thank you.
Yes, thank you, Nikita. nice presentation it was, and really a great work is there. Uh, can you suggest one or two points that how would you like to balance the trade-off between the quality of service and renewable energy uses?
Like to save solar energy and wind energy, sir.
Yes, so these are the uses of the renewable energy, right? And
Yes, sir.
another factor is performance of quality of service means performance.
Quality, yeah, performance. Yes, sir.
So, what are your points to trade off between these two?
So, like I can say that this, balancing renewable resources like wind power and solar power usually involves trade-off between sustainability and system performance. Like there are important factors like latency, reliability, and also energy consumption.
And
So
what
these
is the
are
role of AI in that?
like AI can, with the help of AI algorithms, like which I suggested, like ACO and PSO, these can help you to reduce this carbon footprint and also reduce pollution in, green environments.
Okay, thank you. All the best. Good luck for your work.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter Saiket Helder with the paper titled Cyberbullying Detection Using Machine Learning from Social Media Comments in Bangla Language. Sir, if you're ready, then you may start with your presentation. Sir Saiket? It seems we do not have him in the presentation yet. We'll proceed with the next one. Suryamani Sahu with the paper titled Enhanced Cheetah Optimizer Algorithm for Dynamic Economic Dispatch Involving Integration of Renewable Energy and Demand Side Management. So, if you're ready, then you may start with your presentation.
Thank you. A very good morning to all. I am Suryamani Sahu, a research scholar, MTech research scholar, Gita Autonomous College. Today I am going to present my research paper, that is Enhanced Cheetah Optimizer Algorithm for Dynamic Economic Dispatch Involving Integration of Renewable Energy and Demand Side Management. My paper ID is 482. The outline of my presentation is that is comprehensive DED framework, that is dynamic economic dispatch, and novel enhanced cheetah optimization algorithm, and the multi-objective energy management, demand-side management-driven cost and emission reduction, rigorous comparative analysis, realistic and scalable simulation setup, future-ready smart grid applicability. We'll discuss one by one. First is the comprehensive grid framework. The comprehensive dynamic economic dispatch framework presented in this work provides a unified and realistic optimized platform for modern power system, integrating the thermal generator, renewable energy, pump storage hydro units, and demand side management. Unlike conventional DED model that mainly consider the thermal units, this framework explicitly account for the stochastic nature of solar and wind generation, thereby capturing the uncertainty and variability of inherent in renewable sources. By embodying the probabilistic renewable profiles within the dispatch model, the framework ensures reliable and economical optimal scheduling under fluctuating the generation condition. Then is novel issue algorithm. What is in enhanced optimization algorithm? What we are using, what technique we are using, we'll discuss one by one. In enhanced optimization, the optimizer algorithm is a novel meta-heuristic designed to solve complex dynamic economic dispatch problem involving renewable integration, pump storage, hydro units, and demand side management. Building upon the original Chitta optimization algorithm, which introduced adaptive mechanism to overcome limitations such as premature convergence and local optimal interval. In Chitta optimization algorithm, this is the drawback. We will overcome in enhanced Chitta optimization algorithm. In enhanced Chitta optimization algorithm begins with a chaotic initialization using the logistic map to ensure diverse population distribution. It employs adaptive parameter control and elite opposition based learning and levy flight mutation. These techniques we are using. So for my research criteria, I have taken 10 units and 20 unit test system for this enhanced Chitta optimization algorithm, and we compare with the Chitta optimization algorithm and gray wolf optimization algorithm. Multi-objective energy management. Multi-objective energy management in model power system involve balancing economic efficiency, environmental sustainability, and operational reliability under dynamic conditions. The enhanced Chitta optimizer algorithm address these challenges by integrating renewable energy sources, pumped hydro storage. All these we have already discussed. Next is demand side management driven cost emission reduction. How demand side management is responsible to reduce the cost of generation and emission also. In demand side management, play a pivotal role in reducing both the operational cost and emission in dynamic economic dispatch system by strategically shifting the curtailing the demand during the peak hour. Demand side management flatten the load profile, enhance the grid reliability, and facilitate renewable energy integration. The enhanced optimizer algorithm demonstrate these benefits across the benchmark test system. For the 10 unit system, the demand side management integration reduces the total generation cost from 90, uh, 90 94 9,48,100 for Chitta optimization algorithm, and for enhanced Chitta optimization algorithm is 9,45,800. We will discuss. We will show it in graph. Here I have written in this. Then we will go to the rigorous comparative analysis. In the comparative analysis of the enhanced Chitta optimization algorithm against the original Chitta optimization algorithm and gray wolf optimization algorithm reveals the enhanced optimization algorithm superior performance across the multiple dimensions of dynamic economic dispatch. In terms of cost reduction, enhanced optimization algorithm consistently achieve lower generation cost. For the 10 unit system, DSM integration reduces cost compared to Chitta optimization algorithm. In realistic simulation system, in where I have performing my experiment, the simulation setup of evaluation of enhanced optimization algorithm was designed to be both realistic and scalable, ensuring the application to modern power system. All experiments were implemented in MATLAB 2023 on a higher performance workstation equipped with the Intel i9 processor and 64 GB RAM, Windows 11. The two benchmark systems are selected: a 10 unit thermal generation system and a 20 unit system integration solar, wind, pumped storage, hydro. The 10 unit system reflects the conventional dispatch condition with the dynamic load variation over 24-hour horizon, while the 20 unit system introduced renewable variability and DSM, that is demand side management participants, simulating the real world volatility and renewable profiles were modeled using probabilistic distribution. Beta for wind and Gaussian for solar irradiance, capturing the stochastic behavior. The future-ready smart grid applicability. The enhanced optimization algorithm demonstrates strong applicability of future-ready smart grid by addressing the challenge of renewable integration, demand-side management, and decentralized energy system. As a power network evolves towards the intelligent and resilient infrastructure, issues adaptive mechanisms such as delayed opposition-based learning, chaotic inhalation, and levy flight mutation enables efficient handling of non-linear and multi-objective optimizer problem under certainty. Smart grid require real-time adaptability to balance fluctuation demand. And intermittent renewable supply. What methodology we have used? Methodology, this is the main objective function. The main objective function over a time period D is given. We have taken this as the objective function. where this is the mathematical expression, and CIPT is the cost involved for all the generating units, and PIT is the power output of the ith unit at time t, and SUIT and SDIT is the startup and shutdown cost. This is the objective function, and these are the constant equations. In constant equation, we have taken the emission level, and emission level we have taken this equation, and the alpha, beta, gamma, and delta is the coefficients. It is while chosen in the simulation in the MATLAB, and this is the power balance constant. This is the total generation of all the units we have taken in the MATLAB application, and this is the taken the wind power generation, and this is the solar generation, and this is the pump generation. This is the power balance equation that must be equal to the dt plus lt, where dt is the demand at time t and lt is the transmission losses. And the generation limit must be satisfied. This is one of the constraints to satisfy the objective function, where PIT is the power generation of the ith unit at time t, and this must be within the minimum and maximum capacity of the power generating unit. And the ramp rate limit, mm, this is the constant equation to satisfy the objective function. And this is the spinning reserve which must be required, and this is taken as the spinning reserve equation to satisfy it in the algorithm. And then the pump storage, the minimum, the water reserve level must be maintained in the permissible level, which is between the Hmin and Hmax. And also integration of demand side management. In demand side management include the shifting and curtailment. This pump storage, the total pt pumps must be equal to 0, and this is the mathematical expression, and we are using in the MATLAB, and using all the this methodology in MATLAB application, in coding and in simulation also, we get all these four these tables. We have taken three scenario. In scenario A, we have taken only the standard DD without DSM, standard demand dynamic economic dispatch without DSM and without renewable energy or storage. But in scenario B, we have taken dynamic economic dispatch with renewable energy and pump storage and hydro, but without DSM, that is demand side management. But in scenario 3, we have taken combined all these three, that is dynamic economic dispatch with renewable integration along with the demand side management. We have taken this scenario A and scenario B and
Excuse me, sir.
scenario. Yes.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
So this is the table, and the total generation cost of 10 unit system that I have taken the 10 unit system. This is for enhanced Chita optimization algorithm and Chita optimization and Growell optimization algorithm. In scenario A, the reduction cost is 0.26%, and in scenario B, the 0.27%, and in scenario C, that is integrating all the units, that is the integration of renewable energy, pump storage, and demand side management. The cost reduction is 0.24% of the enhanced Chita pension algorithm in comparison to Chita and Grow Alpha algorithm. Then the emission level, we have taken this from this is the MATLAB application, and this enhanced in scenario C here, the enhanced Chita application algorithm, the emission level is lower compared to Chita. In all the cases, in all the scenarios, the enhanced algorithm is lower. But in scenario C, the integration of demand side management and renewable energy, the enhanced algorithm is better compared to Chita and Growl approach. Total generation curve for 20 unit system, 10 unit system, and then 20 unit system. This is the result analysis. This is the result for cost convergence for 10 unit system. This cost iteration, and this is the emission versus the 10 unit system. Here we have seen the graph obtained from the MATLAB simulation. The enhanced optimization algorithm, so the graph is lower, so that the enhanced optimization algorithm, the cost is lower and the emission is lower also. But in total generation cost comparison, the enhanced algorithm is the lower generation cost compared to Chita and Crowell optimization algorithm. This is the conclusion part. And then I see the appliance algorithm are successful developed, and the demand include the demand side management and the inclusion of renewable energy integration. And this is the future war. That is, we can uh, grow with this. That is large scale deployment, advanced energy storage integration using this, and peer to peer micro gram trading. All these we can pursue in future. These are the reference. Thank you.
So, is anyone wants to ask something to the Suryamaniji regarding his presentation? Sir, it is very detailed work and very good work indeed, I must say. And do you have considered the same quality of service factor during your demand side management?
It will require a little bit rigorous work to complete the implementation of the demand side management. But still, we have taken consider the demand side management for the research work first time.
Okay. So further, there are a scope to do so many things regarding with the quality or cancer performance factor for demand side management, right?
Yes, sir. Yes.
Yeah. All the best, all the very best, Suryamaniji. Thank you for the presentation.
Thank you, sir. Thank you.
Thank you. Over to you, Ishita.
Thank you, sir. I'd like to call upon our next paper presenter. I'd like to ask for Saujanya Patil with the paper titled Hybrid Deep Learning Model for Neuron-Specific Protein Subcellular Localization. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am. Good morning, everyone. Thank you for giving me this opportunity to present our work. Today, I'll be presenting our completed research on protein subcellular localization in neurons. In this work, we four members designed and evaluated an automated deep learning based framework using neuronal microscopy images. In this presentation, I'll be covering the following contents. Firstly, abstract. To begin with, I would like to briefly explain the focus of this research. Inside neurons, proteins are not distributed randomly. Instead, they appear in specific regions, and this arrangement directly influences how neurons communicate and function. When when protein placement shifts, the internal processes of the neuron also change. The main question was explored how protein subcellular localization in neurons can be analyzed accurately. We proposed an automated end-to-end framework that works on microscopy images. The framework takes raw image data as input and generates clear predictions of protein localization. We worked on 4D neuronal microscopy images and applied automatic neuron segmentation. After segmentation, we used a hybrid deep learning approach that combines image-based learning with spiral relationship modeling. And also, this combination allows the model to capture local image patterns and along with interactions between neighboring neurons, leading to consistent and meaningful predictions. To understand why this problem is significant, we considered how neurons function. Firstly, neurons depends on precise internal arrangement to transmit signals effectively. The localization of proteins play a major role in determining how processes inside the neuron operate. Unlike simpler cells, neurons have long extents and complex branching structure. Because of this, even small shifts in protein localization can influence signal flow and intracellular transport.
So if it can lead to these all three diseases such as Alzheimer's, ALS, that is amyotrophic lateral sclerosis, and Parkinson's. So we found our problem statement is that even though protein localization has been explored extensively, neuron introduce additional challenges. Neurons are structurally complex and strongly influenced by their spatial surroundings. Their behavior depends not only on internal features but also on interactions with nearby neurons. Most existing computational models are designed for general cell types. The models analyze independently and focus mainly on image level features. As a result, the neuron specific structure and spital interactions are not captured effectively. So, we have found this gap in R and we have worked and aimed to bridge the model. So, based on this problem, we defined three objectives. That is, firstly, to develop an automated framework tailored specially for neuron level protein subcellular localization. Later, to incorporate spider information so that the interactions between neighboring neurons are included. Next, to ensure that predictions are reliable and biological meaningful across different data sets. Before designing, we reviewed existing work in this area. Experimental techniques such as fluorescence microscopy provide detailed images, but they involve complex analysis. Early computational approach relied on handcrafted features and traditional machine learning models. Later, deep learning improved automation and predictions quality. However, most existing studies focused on general cell types and did not fully account for neuron-specific geometry and spider context. This clearly showed that the need for neuron-focused and spider-aware approach. So these are the related work on protein localization. Later, coming to methodology, we, dis- we designed our methodology by integrating image level feature with spiral information. We worked with 4D neuronal microscopy images containing nucleus, protein, and membrane channels, which we later converted it to 2D. These images were pre-processed to ensure consistency across samples. Automatic neuron segmentation was performed using cell pores to isolate individual neurons. After segmentation, we extracted morphological and intensity-based features. Since neurons interact with their surroundings, spital context was captured using k-nearest neighbor graph. A convolutional neural network designed image-based patterns, while neural network learned relationships between neighboring neurons. The output from both models were combined to classify protein localization into soma, dendrite, and axon regions. This is the raw input data set. Later, coming to results and discussions, this slide represents feature distributions that confirm effective neuron segmentation and support accurate protein localization. As we have given this data set as the input, we later get the output in the graph format. In this slide shows the model's performance with stable F1 score across all regions. The highest F1 score was for the SOMA at 0.94 and the full model achieved an accuracy of 92.4%, showing the contribution of components. I would like to conclude. So we developed an automated framework for neuron-specific protein subcellular localization. By combining image-based learning with spital relationship modeling, the hybrid CNN-GNN approach overcomes key limitations of existing methods. The framework provides reliable predictions and support scalable analysis. Overall, this work contributes to deeper understanding of protein behavior in neurons and support future research in neuroscience. Thank you. And we have worked on 20 references related to our work. Thank you. I would like to be questioned.
Okay. So thank you, Sojanya. Good presentation it was. So any question from the session? Because this time I didn't suitable for asking any question. So I think there is no question from the session. So thank you, Sojanya, for presentation, and it was good enough. Over to you, Ishita. Please take.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon Meet Patel with the paper titled Hybrid Fuzzy FMEA and Neural Network for Intelligent Risk Management and Infrastructure Projects. So if you're ready, then you may start with the presentation. Sir Meet. I believe he's not in the presentation yet. I'd like to proceed with the next paper presenter, Shruti Sahu, with the paper titled Integrating Deep Learning and Ensemble Techniques for Enhanced Waste Segregation in Smart Cities. Ma'am, if you're ready, then you may start with the presentation.
Yeah, sure. Am I audible?
Yes, ma'am, you're audible.
Yeah, just a second. Is my screen visible?
Yes, ma'am, it is visible.
Yes.
Good morning, everyone. My name is Shruti Sahu, and I'll be presenting the paper ID 638, which is titled Integrating Deep Learning and Ensemble Techniques for Enhanced Waste Segregation in Smart Cities. Our work focuses on leveraging advanced artificial intelligence and machine learning techniques to solve one of the most pressing urban challenges, which is efficient waste management. The problem statement for our research paper is that when we were investigating the waste management in India, we found that in fact, globally, 60% to 85% of the recyclable materials still end up in the landfills. And this isn't just a logistic issue, it is also a knowledge gap. The traditional methods like open dumping and manual collection are no longer sufficient for the modern urban growth. The researchers also showed that more than 70% of the residents are uncertain about correct waste classification, and the existing systems often lack the clear rules and leave the consumers also uninformed. So, to bridge this gap, we need automated and highly accurate systems that can categorize the waste at the source itself so that we can help in efficient waste segregation. So, as we are moving towards smart solutions for every problem, so for waste segregation, also we can use automated systems which collaborate artificial intelligence, machine learning, and deep learning, and also help to promote sustainability. So, when we conducted the literature review for the researches which have already been done on waste management, we found that most frequently used models were EfficientNet, SwinConvNext, and custom CNNs, which were used to classify the waste into different categories and hence help in efficient waste segregation. Now, in this study, we used an image data set which was taken from Kaggle. The data set had two categories, biodegradable and non-biodegradable, and it further had subcategories. The biodegradable had subcategories as food, leaf, paper, and wood, and the non-biodegradable had subcategories as e-waste, plastic, and metal. The data set was divided into two types of images: training images and validation images. The total labeled data we had for training images was 15,400, and the validation images were 1,174. Now, in this research, we have proposed the hybrid model as shown on the screen. In this hybrid model, we first input the images and perform pre-processing and normalization on these images. And then these pre-processed and normalized images are fed into two parallel deep learning branches. One branch is the EfficientNet B0, and the second branch is the custom vision transformer. The efficient net B0 extracts the local and text-based features, and the vision transformer captures the global and long-range dependencies in the images. Then the features from both these branches are concatenated to form a cohesive multimodal representation. Then this integrated representation is utilized to train a deep classifier as well as the support vector machine and random forest models. The three outputs are then combined through weighted averaging to derive the final class probabilities. Then we can have used four performance matrices: accuracy, precision, recall, and F1 score. The results are as follows. Our hybrid model gives an accuracy of 92.19, precision of 84.99%, recall of 92.19.
Shruti, sorry to interrupt you, but I think your slides are not moving.
They are not moving. Just a sec.
Yeah, because not in presentation. Yeah, now it's on result.
Okay, so it wasn't moving from start, so I should just scroll once if you have missed.
Okay.
This was the image data set which we used. This is the hybrid model which was proposed in the study.
Okay, go ahead, please.
Yeah. And I'll continue with the results. We got an accuracy of 92.19, a precision of 84.99, recall of 92.19, and F1 score of 88.44%. We compared our hybrid model with the other models which were proposed in the studies which we took into consideration in our literature review. We were able to get a higher accuracy than the other models which were proposed. For example, a study used ResNet 50, which was partially fine-tuned, and it had an accuracy of 90.14. And one paper proposed EfficientNet B0, and it had accuracy of 89.58. And our model gives an accuracy of 92.19. The conclusion is that the proposed multi-staged hybrid model it exceeds the individual architectures, and it also provides a robust pathway for automated waste segregation in the smart cities. And in the conclusion, I would also like to say that by integrating the deep learning with ensemble techniques, we have created a high accuracy system which is capable of meeting the demands of a smart city. And this is a vital step towards sustainable development and a cleaner future. Thank you for your time.
Thank you, Shruti. Good presentation. It was a very short presentation. I would like to know whether you have considered the medical waste for the segregation from the total waste, because in these days the medical waste is creating more problems, right? Especially in the smart cities, like recently you have listened about the indoors problem, right? There is some problems in small cities
Yes.
like Udaipur also. So,
Yeah.
do you have taken the medical waste care in this your segregation plan?
Actually, sir, in this study, we have not taken the medical waste into consideration, but for the future work, we are working on medical waste also, because for medical waste itself, it is a very big task for that purpose. So
Because
integrating it.
ideally it is already segregated, right? But sometimes in this procedure of the collection and dumping, so
Yes,
many times this waste included in matlab merged with the other waste also.
yes,
So
sir.
do you think that there is something by which we can segregate that separately, then we can go for further segregation?
Yes, sir, we have to work on that also. I'll keep that in mind.
Okay. And any specific reason that you have not taken the medical waste in this study?
Actually, sir, we found two, three data sets for the medical waste also, but it was not getting well with the model. Like when we were trying to segregate it, also often the miscategorization was taking place. So we thought of building another specific model for that purpose.
Okay. 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 Very well. All the
Okay.
best,
Thank
Shruti.
you,
Thank
sir.
you. Thank you.
Thank you, sir.
Yes.
Thank you, sir. Thank you,
Over to
ma'am.
you, Shruti.
Yeah. I'd like to proceed with our next paper presenter. I'd like to call upon paper presenter Advaita BK with the paper titled Intrude Ds with a Smart Intrusion Detection System Using Hybrid Machine Learning. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am. Good morning to everyone. Thank you for providing this opportunity to present my work towards you. And my paper ID is 681, introduces a smart intrusion detection using hybrid machine learning algorithms. Hybrid machine learning algorithms. I'm Advaita from Rajalakshmi Engineering College, Chennai. The name intrusive came from the combination of the word intrusion and detection. So only the intrusive name came. Um, the introduction is about the traditional intrusion detection systems fail to effectively detect evolving cyber attacks and often produce high false positives. This work proposes a hybrid machine learning based IDS that combines feature selection and ensemble learning to improve detection accuracy, reduce false alarms, and identify both known and unknown attacks in real time. This is my introduction. So basically, my project is used to find even the known and unknown attacks. This is the one of the best feature in my project. Problem statement is the existing intrusion detection system struggle to accurate and detect both known and unknown cyber attacks in real-time network traffic, and which results in high false positive rates and limited adaptability. So to resolve this problem, I have implemented live detection, like combining all the hybrid machine learning models, supervised and unsupervised learning models, to bring a live detection, which is very easy to find new attacks, unknown attacks, malicious attacks, or any kind of attacks that is occurred in the user system. This is the abstract of my project. The main objective is to develop an intrusion detection system using hybrid machine learning to identify normal and malicious network traffic, to improve detection accuracy and reduce false alarms, to combine multiple ML models for better performance. Why we need intrusion detection system using hybrid machine learning model? So traditional systems does not detect new attacks, and it cannot find what is detected on live. So to resolve this, we need by using hybrid machine learning, we can find if any new attacks are generated. So we can find it easily within a small span of time. So we are using
hybrid machine learning in the intrusion detection system to find the attacks very easily and very quickly within a small span of time. So this is one of the main need my project does. And it combines multiple machine learning algorithms to improve the detection accuracy. Hybrid intrusion detection system can detect both known and unknown attacks, as I said already in the introduction part. And these two are some of the need for intrusion detection used in hybrid machine learning. So how intrusion detection is used in hybrid machine learning? There are 6 steps in general. The intrusion detection is used in hybrid machine learning. The first one is data collection, and second one is data processing, and third one is hybrid model formation, and fourth one is model training, and fifth one is intrusion detection at last. The sixth one is decision and alert generation. These are the common steps how the intrusion detection is used in hybrid ML. So these are the 3 basic types of intrusion detection. One is signature based. The signature based is one of the traditional intrusion detection type, which is used to identify only the known attack patterns, but not the new or unknown attack patterns. So anomaly based intrusion detection is slightly advanced than signature based intrusion detection system. Which is also used to find a known attack pattern and also an unknown attack pattern. But in hybrid intrusion detection, it uses signature-based and anomaly-based, but it is used to find unknown attacks, attacks which is likely detected, and known attacks. These are the advantages and limitations of traditional and modern hybrid intrusion detection. So basically, the traditional intrusion detection is simple to implement and fast for detecting known attacks. Requires a less computational resources compared to ML-based system. The limitation is it cannot detect a new or unknown attack, requires frequent manual updates of attack signatures. We want frequent updates. So that is the basic limitation. And the modern hybrid intrusion detection advantages are it detects both known and unknown attacks with higher accuracy, and it reduces false positives. The limitations are it requires more computational resources and training time. It is also more, it requires more cost. Depends on quality and quantity of data set. So these are the advantages and limitations of traditional and modern hybrid intrusion detection. If you ask which is best, traditional intrusion detection or modern intrusion detection, I say modern intrusion detection is best because the traditional intrusion detection fails to find the unknown attacks or the attacks that is lively detected on time. So the modern intrusion detection is best to detect live detection, unknown attacks, malicious attacks, or anything the attack that is given in live or this is about proposed system. The main objective of proposed system is to detect both known and unknown attacks accurately using hybrid machine learning approach. The data sets I have used is NSL-KDD and CICIDS 2017, in which these 2 data sets are taken from Kaggle. The tools that I have used for this proposed system is Python, Flask, and Jupyter Notebook I have used for data pre-processing and model training. In my project, I have used machine learning models like linear regression, logistic regression, and native Bayes as a parametric model. Non-parametric models I have used decision tree, random forest, k-nearest neighbors for my project, and a hybrid model which combines both parametric and non-parametric models. So the workflow of my project is first process is data pre-processing, model training, hybrid model evaluation, web interface simulation and control. So this is my proposed system module of architecture diagram for my project. And first one is data pre-processing. First step is loading the data set. And second processing is handling missing values. If there is any missing values, it will clear all those errors and it will update. Encode futures, normalize, split, and train. Model training, we have logistic regression, decision tree, and random forest, and some more ML models also included in this. In hybrid model, I have combined parametric and non-parametric models also in common. And the evaluation is I have evaluation, live evaluation shown for accuracy, precision, recall, F1 score, FPR or FNR, and detection rate. It shows in percentage how much the detection rate is occurred. In my web interface, we can upload input and we can select models. If you want to check for parametric model, we can check. If you want to check for non-parametric model, we can check their accuracy, precision, recall, false positive, and as well as false negative. Next one is stimulation and control. I have start and stop, row by row prediction, manual or demo input. Start and stop means we can stop where you want to resume, and we can start where you want to uh, detect. And this is the comparative analysis of my model evaluation. From this, these are the all the ML models and its accuracy, precision, and recall. From this, I can say that hybrid parametric plus non-parametric has the highest accuracy compared to other models. These values are generated by combining the true positive, true negative, false positive, and false negative rates. By dividing it, we will get all these values. And this is the graphical performance of the proposed hybrid intrusion detection. In this also, we can see that hybrid parametric plus non-parametric has the highest accuracy compared to all the other models. You can see that accuracy, precision, recall, training time, false positive rates, and false negative rates are higher compared to all other models. So the conclusion is this model is used to detect unknown attacks and lively detected attacks. In my project, I have used live detection module, recent action module, and system activity tracker. If the system has low memory or if the system has detected any malicious attack, it will indicate at the live point. So this is one of my enhancement in my project. Future work is I want to do even more real-time detection in my future. So that's all. Thank you.
Okay. Thank you, Adita. Nice presentation it was.
Thank you, sir. Thank you, sir.
So, is this your research, PhD research work or your MTech project work?
Yes, sir. This is my basic research work about intrusion detection.
Intrusion detection. And are you following this further for more research in that?
Yes, sir.
In the
I will
same?
follow for doing more research work, as I will take this as an idea.
So, what did you find? Which machine learning algorithm is the best for your this work? Or
Sir,
can
hybrid
say
machine learning is best for
hybrid
this
machine learning.
work. It shows higher accuracy as well.
And okay, higher accuracy is one parameter on which you are saying that the hybrid ML is good. Okay, Adita, all the best for your research. Thank you. Go ahead, please.
Thank you so much, sir.
Thank you. Over to you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. I'd like to ask for the next paper presenter. We have with us Samadha with the paper titled SciencePire, Indian Sign Language Translator using gloss mapping and 2D pose-based visualization. Ma'am, if you're ready, then you may start with the presentation.
Good morning, ma'am. Actually,
Yeah.
I'm Samida's team member.
Okay.
She is not actually present here. So if it's okay, I can
Yeah,
give
sir,
the
you can. You
presentation.
can go ahead.
Yes.
Yeah.
Savannah, right.
Is my screen visible?
Yes, sir, it is visible.
So, good morning, everyone. I am Swanand Kulkarni, and today I will be presenting our research work titled SciencePire Indian Sign Language Translator using gloss mapping and 2D pose-based visualization. So this work focuses on improving sentence level Indian Sign Language visualization using pose-based representation instead of using static videos or alphabet level systems. I will briefly cover the problem statement followed by our objective, a review of existing systems, the research gap, our system architecture results, and finally conclusion and future scope. So, as we know, Indian Sign Language is widely used in India. We have around 2 to 3 million people who are either deaf or dumb, according to the census of 2011. However, right now we have only 200 to 300 certified sign language interpreters, which creates a gap. This creates a serious limitation when it comes to sentence level understanding, especially in education and real world communication scenarios. All the existing systems that we have rely mostly on static sign videos, which makes it hard for a large scale, and it is difficult to extend vocabulary and is unsuitable for dynamic sentence formation. Based on these limitations, our objectives were to enable sentence level Indian Sign Language visualization, to use pose-based skeletal representations instead of fixed videos, to ensure smooth transition between consecutive signs, and most importantly, to handle missing vocabulary dynamically. In order to understand the current state of Indian Sign Language translation systems, we studied several research work published in the between the year 2022 and 2024. Most of these systems focus on converting speech or text input into ISL using traditional natural language processing techniques such as tokenization, stemming, lemmatization, and basic grammatical parsing. The output in this system is usually presented using pre-recorded sign videos, GIFs, or sometimes static images corresponding to individual words or phrases. They do not correspond to a sentence. Some of the system also use 3D avatars where animations are either manually created or generated using predefined sign libraries. While these approaches show reasonable accuracy for isolated words, they struggle significantly when it comes to sentence level translation, scalability, and handling new vocabulary. After analyzing these systems collectively, we identified some common limitations that appear consistently across the literature. The first major limitation was static sign databases. If the sign is not already present in the database, the system simply fails to translate it. For example, if we have a word, we have a word school. So if the word school is not present in the database, instead of making the sign for the word school, it will individually make a sign for each alphabet, such as S, C, H, O, L. So this is where it fails. The second issue is limited vocabulary growth. Most of the systems cannot expand automatically and require manual intervention to add new signs. Third, many systems depend on manual animation creation, especially those using 3D avatars. This process is very time consuming, expensive, and it is not scalable at all. Finally, most existing approaches show poor handling of missing or rare signs, which makes them unreliable for real world and open ended usage. These limitations clearly highlight the need for a system that is dynamic, scalable, and capable of handling unseen vocabulary. To address the gaps identified in existing systems, we propose SciencePire, which introduces a pose-based approach for sign language visualization. Instead of storing signs as videos or fixed animations, SciencePire represents each sign using skeletal post data, where gestures are encoded as joint coordinates across frames. This representation is significantly more lightweight, reusable, and flexible, making it suitable for sentence level animation. One of the most important contribution of SciencePire is its dynamic handling of missing signs. If a required sign is not available in our database, the system automatically fetches a relevant sign language video from a verified source. From that video, it extracts skeletal poses using pose estimation techniques. It converts the motion into standardized dot pose file, and once it is converted into the dot pose file, it is then added to our database as well. This allows the vocabulary or our database to grow automatically over time, which is one of the major limitation in existing systems. Unlike traditional systems that stop working when a sign is missing, SciencePire learns once and then it reuses the word as it is saved in our database. So this is our system architecture. We can either give audio or text-based input. If we are giving an audio input, the audio is converted to the text format using OpenAI's Whisper. Is converted into text using OpenAI's Whisper, which provides accurate transcription. The text is then pre-processed, where we normalize it. We perform tokenization, where our sentence is broken into small tokens. We perform stemming, where the tokens or the words are converted into their root forms, and then it is converted into ISL grammar. So when I say ISL grammar, I mean here the sentences in ISL and our normal English is different. ISL follows object subject verb format. For example, if I have a sentence, I am going to the market, the ISL translation of that sentence would be market I go. So once it is converted into ISL grammar, uh, we find the gloss. We in our post database. If the post exists, it is retrieved immediately from our Cloudinary. And if the word does not exist, we generate the .post file from relevant sources, and then we update the database. Once we have a .post file for each word, we then concatenate and smooth those post files in order to generate our final translation animation. Our animation is rendered as a 2D stickman. Another major limitation in the existing researches is the lack of publicly available large-scale Indian Sign Language datasets. To address this, we created a custom dataset consisting of over 1,000 ISL words sourced from the ISL dictionary by the Government of India. Each video was processed to extract frame level skeletal joint information which was then stored in a standardized .post format. The dataset is fully owned, reusable, and extensible, and can support future research in ISL animation and gesture synthesis. To best of our knowledge, such a post-based ISL dataset is not available in existing ISL animation system. So this is one of the examples. Mhm. In this, you can see the lady is doing an animation or sign language translation for the word idli, and down right, our project is doing the same. However, instead of idli, we have given the sentence "you eat idli," and you can see the visual comparison of the signs. So SciencePire, so the conclusion is SciencePire demonstrate a scalable post-based approach for 2D sign language animation, public deployment, use in public information system for real-time ISL visualization, dataset expansion. We can add more daily use and domain-specific ISL signs and learning-based generation, explore data-driven gesture generation with large post datasets. One of our future work was also of using SciencePire in real time, either video call translations, or if we are using such, if there are online lectures, at times, obviously the deaf or dumb people can't understand what teacher is saying. So we can also integrate SciencePire in those videos as well in for real time generation. And that's it. Thank you.
Uh, Thank you, Suvanand. Uh, Nice presentation as well, and really a lot of work is needed as far as research is concerned in this field, ISL. So, and as you said that your future work is based on the real time. So I wish you the best of luck for that. My doubt, I just want to ask one thing. What is more difficult, text to ISL or voice to ISL?
Sir, I won't say either of it is difficult, as even though we are using voice to ISL, the voice is immediately converted to text format, and then the process is same for both.
Uh,
So
it's a two-step process, voice to ISL, right?
yes,
So first voice to text and text to ISL.
yes, sir.
Because there are so many factors in voice like na pitch and tone and language and all. So because of that pronunciation, which you can say. So my doubt
Uh,
was like, suppose if we are converting it from voice to ISL, as you are saying for the next your future work, live lectures or meetings only. So in that case, there may be few challenges, and I would like to know those challenges, which is basically focus on the uh, preciseness of the conversion. That is what I am saying. So that's why I ask you this question, which is more difficult. But if you are using the two-step like voice to text and text to ISL, so it is text to ISL will remain same. But again, then voice to text may have some problems remain
yes,
with
sir.
that.
We can say one of the major problem would be the not the tone but the accent.
Yeah.
Like we speak different English. If someone is in South, they speak different English. So there might be problem catching the correct word. So at in that moment, text to ISL would be better.
Yeah. And if we are using the two-step in the voice to ISL, so I think it will remain same while it is converting from voice to text first. The same problem will remain there.
Yes.
Yeah, true. Okay, thank you, Savan. All the best. Take care.
Thank you, sir.
Thank you, sir. Thank you. We'll be proceeding on with the next paper presenter. I'd like to call upon Meet Patel with the paper titled Hybrid Fuzzy FMEA and Neural Network for Intelligent Risk Management in Infrastructure Projects. So, if you're ready, then you may start with the presentation.
Am I audible?
Yeah.
Good morning, everyone. My topic is hybrid fuzzy FMEA and neural network framework for intelligent risk management in infrastructure project. My name is Meet K. Patel. Uh, my co-guide is Darshit Shah and JD Pipalia. The content of my presentation is aim, objective, introduction, literature review of my research, advantages of combined FMEA and fuzzy logic and ANN, and what are the challenges which faces in for the research work, and conclusion. Here are the objectives: to analyze the existing literature on FMEA, fuzzy logic, fuzzy FMEA, and neural network based on the risk management method in infrastructure projects. Then to identify the limitations, what are the limitations faced by the conventional FMEA, and what are the advantages which is covered by the fuzzy and neural network, and provide a methodological framework for the intelligent risk management. Here is the introduction. Infrastructure projects like bridge, highway, and smart cities are facing too many risk and uncertainties. For in the traditional FMEA method, failure mode and effect analysis, in this system, proactive risk management techniques used in infrastructure projects to identify the potential risk failure mode, assess their impact, and development preventing measure before the failure occurs. The fuzzy logic and ANN. Fuzzy logic in a construction is the method of dealing with the complex, subjective, and uncertainty information in the industries, improving decision making in areas like contractor selection, risk assessment, and project scheduling. And ANN is work refer as to use of AI-powered system that minimize the human brain to analyze the complex data and solve the problem, improving the decision making, forecasting, and optimization across the industries. Then here is the literature review. The adoption of such hybrid model in a real world application remains limited due to the challenges like data availability, technical complexity, and lack of user friendly tools. Still, in the literature, strong support the effectiveness of the integration fuzzy logic and ANN for approach for proactive and intelligent risk management. The combination offers a balanced approach. Fuzzy logic and handle subjective uncertainty, while ANN enhance the predict accuracy, making it especially suitable for a large complex infrastructure projects where the both type of reasoning are essential. Here are some researches which is used for the for paper. Different researcher find the different uh, uh, key findings with of the researcher. Everyone using only two methods, fuzzy and FME, or the fuzzy and ANN. No one is using three all method, fuzzy FMEA and ANN. In my research, I am using three or all of these methods. What are the advantages of the fuzzy FME combination of the fuzzy FMEA and ANN? Enhancement of fuzzy logic convert the logistic term into the fuzzy number, and benefits handle the uncertainty and values. ANN learns nonlinear relationship, predict the failure probability, and dynamic RNP. Integration of integration, FMEA provides the structure, fuzzy handles the uncertainty, ANN predicts. The more reliable, productive, proactive risk assessment system. What are the advantages? Reduce the subjectivity of using fuzzy logistic variable, handle uncertainty in material, environmental, and project data, predict the failure probability before the occurrence, and support the intelligence and proactive risk decision making. What are the challenges? Real-time data, learning the Internet of Things and the big data analytical for continuous monitoring. Automation, using a AI to reduce to heavier resilience on manual expert input during the risk identification. And scalability, testing framework on a mega project like the smart city or the extensive transport. Conclusion. Main summary is the hybrid approach is effective and address the subjectivity and rigidity to traditional FMEA. Enhance the prioritization and provide a robust tool for optimizing maintenance schedule and reducing life cycle cost. These mark a significant step toward the proactive and accurate infrastructure management. Thank you.
Thank you, Mr. Patel.
Yes, sir.
Thank you very much for your presentation. It was a good presentation, and you covered some of good points during your presentation related with the fuzzy logics. Is there any question from the session? Because this time again, I am not finding myself suitable for that. Okay. So, thank you, Meet. Thank you for your presentation, and
Thank
all the
you.
best for your future research.
Okay. Thank you, sir.
Over to you, Ishita.
Thank you, sir. This brings us to the end of the presentation. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version of the conference and all the previous 9 versions. We will be happy to see you in the 11th version in 2027. I'd also like to thank our session chair. All our presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCon 2026. For our session chair, thank you, sir, for your valuable presence, sir. A token to the chair on behalf of Team SmartCom
Thank you.
26 and Global Knowledge Research Foundation.
Thank you.
Thank you, sir. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.